Okay, so to make a complex shape out of flat steel sheet metal requires a lot of measuring and calculating. And then, you got to cut it all out, and then you got to weld it all together. So, this is the first part you're seeing where I'm figuring out where I got to cut it to make this housing for this bearing when I weld it back together. Okay, well, this is the part where I'm making the mount for this guy. And I basically, some thin gauge steel. I preform it by clamping one end of the strip on that piece of aluminum tubing with a pair of vice grips. And I get the preliminary shape, and then I just work it by hand with, using pliers for leverage until I get it where it just sits right around this guy. See? Close enough, because I'll actually index it when I weld it. So I have the radius so close now that it's going to be perfect. Well, not perfect, but close enough for government work, baby. That ain't gonna work. Okay, so this is the two pieces, and one of the curved ones. This is going to make the main shell. You can see I've cut them all down. I've got that bearing kind of centered there while I tack it. Now I'll take it out and I'll finish welding it. But I won't do that until I'm sure I'm ready to weld everything, because it's too hard to take apart. Well guys, now we're doing this full welding on this guy. I've got it all tacked, and I'm going to just seam these edges on 4 edges, so I'll get a little bit of it on video for you. It's TIG-in, and then I'm mostly fusion welding. If I run into a spot I have to drop a little bit of filler in, I will, but it's set up mostly to just fuse these pieces together. You get less grinding. So, stand by. Oh, not bad.
Especially considering my friggin' ground ain't even clamped on. Not bad. So anyway, enough of that. Hey everybody, Kim here back again with this stick splitter. So I got the bearing housing done, and this support bracket that holds the end, it set the depth of the drumstick in the fixture. I had to go through a whole lot of measuring and indicating and figuring and calculating to figure out how thick this needed to be. And it's funny because I had this inch by like, can't remember what it was originally. It was a big plate, but it's inch thick, a little over in weight. Turns out it was like within 0.6 of a millimeter this way, the width. So I just machined it down there, get it on there, let's see. Yeah. So what I got to do now is a whole bunch of machining on this guy with a mill. I had to put a slot in the bottom to ride on a piece of key stock to keep it centered, and also to have a hole to attach it to sink it down to the key stock, which involves a slot. And then I got to taper these ends up to meet closer to the center of the radius of this thing, because it'll look cooler, and it'll also take some weight out and make it less bulky. But it's going to end up right about here. Let me move this little guy. Old height gauge. That's what I've been using. Anywho, I want to taper this out like that, you know, so that it goes up and it's going to be welded onto this piece. At the end, I'll square it all up, fix it together, lined up perfectly, and then I'll weld it, you know, make it into one piece. So that's the plan. Stay tuned for this bit. It's all okay. Here's this convoluted little clamping setup on this little sign vise. It's a tiny little vise, and I don't have a whole lot of clamping stuff. Really need to make some time to build some, you know. But you can see how I get my height in there. I get a little friggin' gauge block and just the right size feeler gauge in there to get my angle. Now this thing is absolutely not critical, it's all cosmetic. So mostly I go by the line. If I had to really do a super precise angle with this sine vise, I would have to have some really good gauge blocks. But yeah, I don't see that happening anytime soon. Because all I'm doing is tapering this block. I'm going to do a real quick one here to just discuss some fabricating stuff on this stick splitter. So let me zoom this in so I can show you some things and explain. Alrighty. So this is the first part I made. Right here. Let's see. That's probably a better spot. Right about there. So this piece of brass, it's really easy to friggin' machine. I just put a slot right here, put a hole right here, 2 countersunk holes for screws that hold a razor blade in that hole, and it's got a piece of Delrin shims in there to back it up. Easy to machine. Now, these 2 parts right here. This is the hub and this is the tube that holds the thing together. You know, that holds the drumstick, goes in here, like so. Right? This guy has got a taper that matches this taper. I'm going to put it in there. It will grab the drumstick and hold on to it. Again, if I can get it apart, I won't. So, set those aside. These are lathe and stuff. So, and then there's this guy. Not enough room, right? Sounds like it's not really paying attention. Oh, here you go. Now here's this guy. It's a little different. This is all cutting and welding and fabrication. No machines at all except for cutting this round hole. Pretty easy. But then, what about this guy? These 2 pieces. These 2 pieces go together like this. And this is a complex shape. Now I make this on a lathe and make this on a mill. But they go together like this. And I had to weld them. I mean, you could make one out of a giant piece of aluminum, but you would throw a lot away. So to index this guy, for me to weld it, here's the tip. Let me go on a little closer, if I can. I need to put this here and weld it on there, and I need to hold it while I do that. And how do you do that? How do you weld, how do you fix this together while you weld it? Well, it's a simple little trick, little machinist trick, or fabricator's trick, I should say. I indicated and drilled 2mm holes in both sides, and I put 2mm pins in those holes. Now I on purpose made those holes just like 2/10 of a millimeter wider on this one than on this one, so that when you go to put the pins into the holes, they don't really want to fit. You have to kind of force them in there. If I can get it right, you got to make sure you got it all right. Here it is. Because those little pins will bend a bit. Come on now. Those little pins will bend a little bit and line this guy up. Okay, so now we'll put this guy right here. See? It holds it together. See? So I'll clamp this down, probably in a vise, just put in a vise, and I'll lay a bead, let it dry, what a dummy. I'll let it cool off, and then I'll finish up welding it, and I'll have this guy as one piece. Pretty cool, huh? Oh, this way. This way? Complex shape. So imagine trying to machine that. If I had a CNC mill with like 5 axes or whatever they are, you could do that. But I did this in a couple of days with basic hand tools, manual mill, manual lathe, and then the finishing thing will be, I will AC TIG weld it to make one part. So that's the trick. So here is my, it's a dry fit of all of the components for the stick splitter up to date. And the last part that I have to build is the moving jaw. And so the moving jaw will hold this guy. And I have to be able to adjust this side to side. So in other words, let me turn this around, sitting on a block of aluminum. Okay, I'm going to pull this back a hair. There you go. So this guy has to be attached to this too, because this is the one that's being drawn in by the lead screw, or the jack screw, or whatever you want to call it. And so it will pull this guy straight in to actually do the cut. So this is all dry fit. You can unscrew this, and when the collet is attached, you can, come on now, you can turn it to the next hole. If I can find the next hole. What's going on here? Oh, I had it way out. So this guy could index 8 divisions in a circle, a radial set of divisions. So you could take the pull this in again. So you can split this guy once, rotate it 1/8 of a turn, and make 8 cuts, and it would be a radial pattern. But if you want to cut a squared pattern, like horizontal lines, turn it a certain amount, whatever, this blade has to slide back and forth a little bit. So I'm going to make a mount that this blade holder will drop into, and then it'll have a couple of adjusting screws that you can center it back and forth just enough so that it can cut incrementally across a horizontal plane, or a vertical plane I should say. So this guy will shift horizontally and make cuts vertically that are indexed in a line. So at the end of the day, it gives a lot of adjustment for the drummer to make different kinds of cuts in different configurations, see how it sounds, and experiment. And if he finds some set of cuts that get just what he wants, what he's looking for, he can write down the numbers, the details about how he did it, and this jig will make it possible to be very closely repeated every time. So that's the point. So I got a piece of 3/16 hot rolled plate from Lowe's, and I'm going to make the moving jaw assembly to hold this. That's what's coming next. Like I always said, I get the weirdest stuff.